Hi everyone, welcome back to my number sense series. In this video, we're going to be doing part 2 of our base conversion basics. In the last video, we talked about how to convert from other bases to base 10. And in this video, we're going to talk about going the other way. How can we convert a base 10 number, a number that we're already familiar with, into another number in base 6, 7, 3, 5, things like that. So let's do a little bit of a recap on what it means to have another base first. For example, if we have a number in base 6, what does that actually mean? Well, let's say that we have a 3-digit number in base 6, like this, this, and this. Now, recall that a value of a number comes from the sum of its digits values, which are related to the place values. For example, in base 10, this place has a value of 1, and this place has a value of 10. Similarly, in base 6, this place has a value of 1, this has a value of 6, and this has a value of 36, or 6 squared. So if we wanted to convert 91 to be a base 6 number, we would have to say, okay, how many 6 squareds are in 91? How many 6s are in 91? How many 1s are in 91? Well, in order to do that, what we have to do is first figure out how many 6 squareds there are. So basically get the biggest parts in there first, and then it'll be broken down to a smaller number. And then we look at that smaller number and we say, okay, how many 6s are in that number? And then we say how many 1s are in that number. So for example, in 91, how many 36s can we fit, right? 91, well, we say, okay, we could fit a 36, but 2 times 36 is 72. We could fit a 72 in there, but 3 times 36 is 108. So we can't fit a 3 here. So it'll have to be a 2. Then after we have 2 times 6 squared, what do we have left over? 91 minus 72 is 19. So we have 19, and 19 is going to be the value of these 2 digits. So remember, all 3 of these digits add up to make a value of 91. But we've already said that this digit needs to have a value of 72, and I'll explain why it needs to have a value of 72 later, not, like 36. I'll explain why it has to be 72. So we have 19 left to split between these 2 digits. Now, it's a similar process for these 2 digits, and now we're just asking a much easier question. How many 6s go into 19? Well, after a little bit of thinking, it's 3 6s, right? 18 is less than 19, so it'll be 3 6s. And then this, we just have 1 left. How many 1s go into 1? 1. So our answer is 2, 3, 1. But you might be looking at what I just did, and you might say, okay, well, why couldn't I have just had a 1 over here and then carried this other stuff over to these digits? Well, let's see what happens if we try to do that. For example, let's say we only decided to put a 36 here. So this digit would be a 1, right? Well, then what we have left is 55. So let's write a 1 here. And now we have 55, value of 55 left to split between these 2 digits. Well, how many times does 6 go into 55? 6 goes into 55 9 times. So you'd have to write 9 and then a 1 here, which looks okay until you realize that this is a base 6 number. Just like how in base 10, the biggest digit we can have is 9, in base 6, we cannot have a digit that is greater than 5. Because if this is a digit greater than 5, you've done something very wrong, because it should overflow into the next digit. Just like how 2 plus 9 isn't a 1-digit number, it has to go into the tens digit. Here, if we have a 9 here, it has to go into this other digit. So what this would be is 9, and then this would overflow 1 and leave 3 here. So it would be 2, 3, 1, just like it is over here. So if that didn't make too much sense, hopefully it'll make a little bit more sense when we do one of these examples. For example, 69 base 10 converted into base 7. How can we do that? Well, first we think about, okay, kind of estimate how many digits is this going to be, right? Think about powers of 7. What's the biggest power of 7 that's less than 69? For example, some of you might know that 7 cubed is equal to 343, but obviously we're not going to have a place value 343 over here because 69 is less than 343. So our biggest digit is going to be a digit with place value 49, or 7 squared. And our other ones are going to be, of course, 7 and 1. So what is this? Well, how many 49s go into 69? Just 1. That leaves us with 20. So we have to split 20 between 7s and 1s. And once again, we're going to look for the maximum amount that we can put in each digit descending. Otherwise, we're going to end up with a situation like this, 191, where the biggest digit we're allowed to have is 5. That just completely breaks the rules. We're not allowed to do that. So how many 7s go into 20? Well, 7, 14, 21. Okay, can't do 21, so it must be 14. 2 7s go into 20. There's a 2. That leaves us with 6. So our answer is going to be 126 base 7. And, it looks a little weird going from a 2-digit number to a 3-digit number, but this is just what happens when we convert to smaller bases very often. And you're going to see this in even more detail in 3 and 5, and maybe in the next video when we talk about base 2. So our next question, 43 base 10, converted into something base 3. Now, 3 is a pretty small number, and so when you scale it up more, its powers aren't that big. And, to demonstrate what I mean, let's do powers of 3. It's 1, 3, 9, 27. So 27 can actually go into 43 once. So that means we're going to have a 4-digit number with place values 27, 9, 3, and 1. Once again, that's 3 cubed, 3 squared, 3, and 1. So how many 27s go into 43? As I said, it's 1. So 1. And then with these 3 digits, we have to distribute a value of 43 minus 27, which is 16. So how many 9s go into 16? Once again, it's just 1. So then we have a value of 16 minus 9 left to split between the 3 and the 1. So we have to split 7 between 3 and 1. How many 3s go into 7? It's 2. And we're left with 1. So 43 base 10 is 1121 in base 3. And so you can see this time we went from a 2-digit number to a 4-digit number. So you can see the smaller your base is, the longer your answer is going to be. And you might even see this, and it goes in the opposite way. If you were converting from base 3 to base 10, your number would most likely shrink because the place values are larger. So you're going to need less place values. Okay, next question, 70 base 10. Once again, we're working in base 6. Now, 70 base 10, we're going to think about, powers of 6 again. What's the biggest power of 6 that is less than 70? It's 1, 6, 36, 216. Definitely can't be 216. So we're going to stop at 36. Now, how many 36 goes into 70? Well, 76 is close to going into 70 twice, but it can't. So we're limited to just 1. So it's 1, 36. Then we're left with 70 minus 36, which is 34, to be split between 6 and 1. Now, 6 is actually, 30 divided by 5. So 5 6s go into 34. Then we're left with just a value of 4. How many 1s go into 4? Obviously, it's just 4. So we have 70 base 10 equals 154 base 6. And maybe in a future video, we'll see how we could have arrived at this conclusion a different way by noticing how 70 is actually 72 minus 2. Or actually, I'll just explain it right now. Now, 70 is 72 minus 2. And maybe to some of you, this doesn't seem like a huge deal. But maybe it's more obvious if I go back to base 10 with an example. For example, think about the number 998. What's special about that number? Or the number 999. What's special about these two numbers? Well, nothing really, except for the fact that it's 1,000 minus 2 and 1,000 minus 1. 1,000 minus 2 and 1,000 minus 1. 1,000 is a really nice number, and 2 and 1 are very small numbers. So, kind of computing these two numbers is pretty easy, as opposed to me asking you to add something like 476 plus 522 to get, 998. Hopefully that was correct. So we can kind of actually use this in other bases as well. 72 is 36 times 2. So 36 goes into 72 2 times very evenly. So if I wanted to write 72 in base 6, what I would write is 2, because 2 36s go into 72, and then I have a remainder of 0 for the other two digits, so it's actually 200. And so you can see 200, that is a nice number. But our answer isn't 200 because we're thinking about 70. So 200 minus 2, that's what we have to compute. So let me get 200 minus 2, and remember, we are working in base 6. Now, if we were working in base 10, the answer would be 198. Because what happens, we do this process. We have to do, okay, what's 0 minus 2? Well, we can't do 0 minus 2. Let's borrow. But wait, this is a 0. We can't do that. So let's borrow from here. That makes this a 1 and this a 10. But we have to borrow. So this is a 9 and this is a 10. And this makes 10 minus 2 is 8. 9, 8, 1. So our answer is 198. So what happens if we try to do this in base 6? Well, once again, can't subtract 2 from 0. Can't borrow from here. So let's make this a 1. And now, think about this carefully. When I borrow this 1 and I give some of the value over here, I'm going to write 10, but it's not 10. It's 10 in base 6. And what is 10 in base 6? It's 6. So once again, if I want to borrow another one from here, 10 minus 1 is not 9. It's 5 because we're working in base 6. So this becomes a 5 and this becomes a 10. But once again, it's not 10. We're not doing 10 minus 2 in base 10. We're doing 10 minus 2 in base 6. And 10 in base 6 is 6. So really, we're doing 6 minus 2. Hopefully, you were able to follow what I'm saying. That gives 4. And so this is 5 and 1, and we got 154, the same answer that we wrote over here. Now, just to compare these two answers, 154 and 198. 9 is the biggest digit that you're allowed to use in base 10. 5 is the biggest digit that you're allowed to use in base 6. And 4 is the second biggest, and 8 is the second biggest here. And it is just because it's, minus 2. So 2 down from 6, minus 2, 2 down from 10. If this doesn't make sense to you right now, don't worry at all. I just decided to do this spontaneously, but this is something that you're going to be able to figure out much more easily as you just get more practice with other bases. So, last question, 108 converted to base 5. Now, base 5 is, a little bit interesting, in my opinion. It's a little bit easier to work in. Just a little, though. 108. So, once again, let's think about powers of 5 to see how big our number is going to be. It's 1, 5, 25, 25, then 125. 125 is bigger than this, so we're not going to have a 125 place value. So it's going to be, once again, 25, 5, and 1, a 3-digit answer. How many times does 25 go into 108? Well, you should hopefully know by now that 100 is a multiple of 25, and it's 25 times 4. So we have 4 25s. What does that leave us with? A value of 8 to distribute between a 5 and a 1. How many 5s go into 8? Just 1. So 1 5, and we are left with 3. No other option but to put it in here. And so our answer is 4, 1, 3. Not so bad, but really the thing you have to get used to with this is doing it all in your head, keeping track of, how much value you have left to allocate to these digits and, working with powers in your head. So I've written out every step in this video, but really do be careful that you're going to have to do all of this in your head during contest. So one piece of advice is to just get more practice, but another piece of advice is to memorize your exponents. As I've said, they are so important in number sense. So this is how to convert numbers in base 10 into other bases. In future videos, we're going to explore the idea of converting numbers from maybe base 2 to base 8, from base 4 to base 2, without using base 10 as an intermediary. But that is a very special case, and it is hard to understand that case without understanding other things first. So hopefully this makes sense to you. If it doesn't, please drop a question in the comments below. I will answer it very fast as I can. And yeah, that's going to be it for today. Thank you guys for watching, and I'll see you next time.